The primary issue is we run a public safety radio system that has to be available all the time. We can't afford any outages, and whether it be a lightning strike or some other reason, we just can't have an outage. When a fireman or a policeman need to push the button, they need to get through every time. We have 9 tower sites. We also have 10 911 centers.
We are at the Orange County 911 prime site. This is their main communication facilities, one of many within the county. We were hired by 911 to come in and improve their grounding and make their surge capabilities reliable. As you can see, there is hundreds of thousands of dollars worth of equipment here. What we did is we paid a lot of attention to detail, not only how we would ground the equipment, how we would ground the racks, but also how we would isolate those racks. You can see what we did up there was all the ground terminations are double lock nut connections, stainless steel bolts. We have #2 insulated green grounds that go directly to each piece of equipment. And that is also on a lug with a lock nut and firmly connected. Each cable is tagged at both ends. All the buses are tied together with 3/0 bare copper. All of the cable trays at any of the joints, we use a bonding conductor across the joints. So what we're trying to do here by tying all the cable trays, all the ground buses, all the racks, and all the equipment, we're trying to establish a uniform resistance and equipotential with all the metal conducting components that are in the facility. Well, one of the things we did that we felt was really important at this site is we put a 3/0 bare copper counterpoise around the entire building. You can see here, this is one of our ground access boxes. In each ground access box, you have a Cadwell connection, not an approved ground clamp, a Cadwell connection. And the reason that this box may look big to you is because it allows you to have access to the ground rod to put a test instrument in the access box. So often people just take a normal 6 or 8 inch pipe sleeve, and it is great for the visual observation of the ground for any kind of degradation, but you can't get on it to test it without digging it up. So in here, one of the things that 911 will be doing on an annual basis is actually taking a resistance reading of this ground rod. Now, at this particular ground rod, as with all of the other ground rods that tie all that 3/0 copper counterpoise together, we drove the ground rod till we got 5 ohms resistance maximum at the rod. This particular 3/0 bare copper ground goes up to the halo. The halo is tied together with all the copper ground buses, and then all the ground buses are tied together with insulated #2 green conductors to all the racks, to all the equipment. So basically trying to establish this, good ground potential between all the metallic components throughout the entire building. At the same time, by code requirement, this particular ground tied to the lightning protection system at the tower is also tied back into the main ground conductor. At the main, and I say that very specific because at the main is the only place where you should have the neutral and the ground connected together, and that's where your ground reference should be established for everything that comes outside to the inside.
There's an awful lot of companies out there, but a lot of them sell, their version of grounding, and they're not really interested in doing something different than what they normally do. And because of the environment that we're in, we have such a high amount of lightning, and it's absolutely critical that we have just a tremendous grounding system. We can't afford not to. So something cookie cutter out of the box is just not going to work for us.
We're at the Claricona Tower site. This was part of the grounding project that we did. We started initially by regrounding the exterior of the site. the tower itself and the counterpoise ground ring around the tower. If you look up, you can see where the attachments were made to the tower transmission lines, and they were brought back down and grounded to the tower base itself, which in turn come down and they go right back to earth ground, which will capture the ground ring around the building. On the wall, it's called bulkheads. These are where all the transmission lines enter the building. The original contractor we had put the grounding straps in the ground, but never actually connected them to anything, and they covered them back up with dirt. So when we came back in to do the second phase, when they dug it up, they found out that none of the grounds were actually connected. They just put them in the ground and buried them to make it appear they were connected. And that's where we had to add, we went back and we made sure we added the second ground back to that to make sure we had a good connection. This unit here is the main TVSS for the site. This protects the incoming power to the building. This unit will protect all phases of the power coming in. It will also give us different readings on the system, voltage readings, whether we took any swells or surges, and we can go back into the history and look and see what our power conditions were like during certain times, and we can tell whether we had a surge in this building at all. We protected the inside of the tower from the incoming power by replacing all the TVSS equipment. We've gone through and replaced all the grounding halos, added to them. We left the existing in place and added to them. And we've also regrounded every rack in the site, as well as all the equipment on each rack. We went through and isolated all the racks from the floor with isolation pads. This was to keep lightning from coming up through the floor, which we've had at other sites. We've also added new technology with the lightning strike detector. These racks I'm standing next to here are all of our transmitters. These are actually repeaters that actually carry the traffic back and forth. As you can see, everyone has a ground onto it. The racks themselves are all grounded, and everything comes back to a main ground bus bar located up on the wall. If you pan up, you see a ground bar that is well over 4 feet long that houses all of the ground bars for this one rack.
We had a major lightning strike at one of our sites recently where we had a technician actually inside one of the transmitter buildings, and he described the sensation of the hair on the back of his neck standing up and hearing a loud, he described it as like a sonic boom, and the power blinked, but then we really didn't sustain any significant damage as a result of that. And so we think that was basically a direct hit and at one of our larger tower sites, and so it could have been catastrophic to our system, and we basically suffered minimal damage, if any.
The lightning actually struck this building direct on. Even with the tower right beside, the lightning does strange things. And when that happened, they didn't lose any equipment here whatsoever. Matter of fact, the technician said, "We didn't even see a blip." Those were his words.